this presentation, I will start my discussion first with the existing air defense. That means the air defense systems are designed to intercept the incoming aerial threats. And aerial threats, I am talking about the fighter aircrafts, the enemy aircrafts, UAVs, the kind of drones which they will be firing against us, or the swarm attack, the saturation attack. So towards that, a lot of technologies are being developed, and good level of maturity is also been achieved in terms of the various kinds of missile system. Like here I'm mentioning very short range to long range missile system. We do have a directed energy weapon system also to intercept these kinds of drones. And not only about these fighters or UAVs, we do have a solution with respect to the incoming ballistic missiles also, where we can intercept these missiles at the exo-atmospheric as well as indo-atmospheric level. But here I am going to talk about a new kind of missile system which has a combination of these characteristics. That means they are coming with a very high speed, like a ballistic missile. Secondly, they do have a maneuverability. At any instant during the flight, they can maneuver with a high G value. And third and important aspect is they are having this high speed within the atmosphere. So these three combinations are very, very critical to avoid any kind of missile air defense system. And today, as of now, we do not have a proper solution against these kind of missiles. And that's why all the countries are moving towards this technology and try to get this hypersonic missile system as early as possible. So with this, we'll go. So this is how my presentation I'll be covering. I'll start with the certain introduction of this hypersonic missile, followed by the classification of this hypersonic missile system. There are basically two classes, the glide vehicle and the cruise missile. I'll be covering both. Globally, as I'm saying, the countries are moving towards this hypersonic field. So how much the development, how far the development is been done by different countries, those parts I will be covering. And there are many critical technologies which are involved in this hypersonic category, right from the mission level to the hypersonic aerodynamics, the scramjet system, which is the powerhouse for this hypersonic system, material which plays a very, very critical role. I will also talk about the technology collaboration, because we all have to work together to have these technologies. And finally, the DRDL's experience in this niche technology. So to start with a hypersonic weapon, so as I was mentioning that these missiles combines the speed of a ballistic missile as well as they are flying at a very low altitude. And why it is critical to fly this low altitude and at the same time to have very high speed? This can be understood with this particular graph which I am showing on the right side. Here on the x-axis I am showing the range that traveled by this weapon, and on the y-axis I am showing the height that will be covered by these missiles. So the dark black line I am showing is a typical ballistic missile profile which will follow a parabolic path and it will impact the target at a certain desired range. Here I am showing the ranges of the order of 3,500 kilometers. Here if you can see, a dotted curve is also been shown, and it shows the point from where on the radar will start picking up or detecting these type of targets. So what it indicates that it is in a position to detect these incoming ballistic missile where still 800 seconds are there available to the guarding system to carry out any command and control functionalities. So the time gap is available with us, and using these time gaps only the various solutions are being worked out as a ballistic missile defense shields. But now let us focus on those two lines which are being drawn at the bottom, that is the green and the blue lines. These are the hypersonic missile profiles which are coming at a very low flying. And we can see that at what instant it is being detected by the radar. It is giving a very, very small range or the time available for the enemy air defense system to track, detect and fire any interceptor against this missile. And this is that advantage what hypersonic missile has compared to any other kind of other class of missile. And that's why these are very difficult to intercept. So same thing I'm showing this via these curve on the left side, where the red path is for ballistic, The green curves or the cyan curve I am showing are the typical hypersonic missiles. And these missiles are not only traveling on the straight path, but do have a capability to maneuver. So any kind of enemy air defense system which are available within the path, they can also avoid those and intercept the intended target. So with these features, that is high speed, maneuvering, and they are very effective against this time critical target. That means I want to reach to that target as early as possible, which can be seen via that box where I am showing that for a 1,000-kilometer range, wherein a Tomahawk class of missile or nearby will take nearly 75 minutes. With supersonic or BrahMos class, we can reach in 17 minutes, but here we are talking about the hypersonic system, which we can reach within the 9 minutes or even less than that. So these key features are critical for our military advantage. So let us now focus on the type of this hypersonic weapon. So there are two major classifications which are under this category. The one we call it as a hypersonic glide vehicle. In this particular class of missile, there is a booster rocket motor which takes a glide vehicle, which is on the top of this booster. So after the boost phase is over, these glide vehicles are ejected. And these glide vehicles which are unpowered will use a skip and glide phase trajectory move towards the target. Typically at the point of ejection, the Mach numbers are of the order of 15 max or more than 10 max, and thereon it will come down towards the target. So these are unpowered. This is only the initial speed is given and later on it glides. While the second category which I am talking about is the hypersonic cruise missile. In this particular category, against the booster will take this kill vehicle to a certain height, it will eject that kill vehicle. Thereon, the hypersonic cruise missile used a powered propulsion system, and here I am talking about scramjet combustion ramjet system. So that is what a scramjet related engine is being used for this hypersonic cruise missile. The down curve also shows that the advantage of this HCM or HGV, like the ballistic path is shown as a blue curve, if you can concentrate on the down part, while the second part, which is the HGV and all, they can do the maneuver in between and give me a wide area where I can intercept or engage the targets of the enemy. So these are the advantages and classes of our hypersonic system. So let us talk about the first class, that the first category, that is boost glide vehicle. So these are launched by the rockets, as I was mentioning, a typical trajectory I am showing here. So it comes to a higher height of the order of 200 kilometers or so. Thereon the petal opening is there from the top. And then the glide vehicle is being ejected, which then is going down. Now here the communication with these missiles also play a very important role, as sir was mentioning about the 5G and the quantum computing. Here, since the ranges are of the order of 3,000 kilometers and above, so line of sight constraints are always there. So it is only via satellite we need to communicate with these missiles. And there should also be a two-way kind of data link communication. Not only I am going to say what I want, but missile also should be telling me what is the current status of that glide vehicle, and accordingly we can turn, maneuver it, and move towards the target. So the satellite communication is going to play a major role for these glide vehicle or hypersonic class of missiles. Since with this communication, these missiles also have an unpredictable long-range trajectory, so they are very difficult to track by the ground radar. Like in the ballistic missile, once the target is been detected, the entire profile can be calculated with the backside in the computer system. While here at any instance, since I can maneuver, so it is very difficult to track and find out where the intercept point is going to happen. So these are the further advantage which are very, very typical about the hypersonic systems only. And the system can be used for both tactical class as well as strategic class. That means the kind of payload it can use as a tactical fragmented payload or nuclear payload also. So globally, if you see, Russia, USA, China are developing this class of missiles, though other countries are also there, but they are still at the development stage or at the fundamental research level. While coming to the application side, Russians have developed these avant-garde and the Kinzhal missiles. You might be aware that Kinzhal missiles recently been fired in the Ukraine war also. So this Kinzel is a air launch aeroballistic class hypersonic system which can have a speed of more than 12 Mach. It can cover ranges up to 3000 kilometer with a payload of the order of 500 kg. So this is already under operational system. Similarly, USA is developing a number of glide vehicles. So here I am showing one of the glide vehicle as AGM 183A. They have recently tested, or the reported one is during the September 2022, and the claim is they can go up to 20 Mach as a peak velocity. China has also developed a number of glide vehicle category hypersonic system, DF-17, which there is a typical picture of DF-17, and the claim is they can go even up to 10 Mach, and ranges they are able to cover up to 2500. The claim is that the missile is already under operation with services, and the year is 2017 onward. So I can say a good level of development is been observed in the glide vehicle class missile, but when we go up to the cruise vehicle class, where it is not unpowered, it is powered, and for powering purpose, we are utilizing scramjet system, that is supersonic combustion ramjet. These missiles are more of tactical nature. They can be, they are of lightweight compared to the glide system, because we don't need to fire these weapons to bring these up to 10 Mach or 20 Mach and then just push it around. We can go up to 4 to 5 Mach, and there on the scramjet itself will take care and go as a powered phase and cover the desired ranges. But this brings a lot of complexities also, because scramjet systems are very, very difficult. It's like combustion you are doing at that 5 to 6 Mach throughout the thousands of seconds. So it's a very complex affair. I am going to cover some of the fundamental and application problems related to the cruise missiles. These are, as I was mentioning, this comes under, mostly under the tactical missile class, and the ranges are right from 600 to 1200 kilometer. Though the system is capable of carrying both nuclear as well as the tactical kind of warhead. With respect to the global development on this cruise missile, what has been available in the literature is that the Zircon missile by Russia, they have already deployed this system, and recently, as per the report, they have fired it also during this Ukraine war, where the typical speed they can achieve is up to 8 Mach, and the ranges are of the order of 4,000 kilometer. And the payload, they were mentioning 300 to 400 kg class. USA is also trying to develop, but they have not reached to the stage where the system is under deployment. They are still in the development phase, though the activity of this development started right from the 1990s, but still they do not have any system which is operational. Here I am showing one of the X-51 class hypersonic cruise missile system, which they have tested in 2013, and the maximum reported scramjet duration operation was 210 seconds. The right side, I am showing a table where they tried to develop and did a number of flight trials, but many of the failures were observed. Sometimes certain control failures, or sometimes the thrust is they were not able to produce much. It's all the game of thrust and the drag. So if the thrust you are not able to produce, the drag will overcome you, and the mission will fail there and there. So they started further like a hypersonic air-breathing weapon concept is a new missile where they are working on, and started the operation, development activities from 2015 onward. I just want you to focus that this particular project was for 9-year duration, and the costing was $15 billion. That is 1.27 lakh crore. And even after the 9 years, like in 2024, they have come up asking that we do need some more time, some more money, and that now the project sanction is MOHWC, that is more opportunity with hypersonic air-breathing weapon concept. So the cruise missile is quite complex then compared to the glide missile. So all the efforts are there how to make these missiles operational. Though Russians' claims are there that the Zircon is an operational up to 1,000 kilometer range. So coming to the, I will now just talk about the critical technologies, and here I will be presenting, as I was mentioning, the cruise missiles are more complex. So I will be covering what are all the critical technologies are there, which are associated with the cruise missile. Glide vehicle class technologies are mostly subset of this one, though the temperatures are quite high, so we may have to go for more better thermal insulation in the glide vehicle class. In this particular slide, I am showing the various areas where we need to focus upon to develop a hypersonic cruise missile, and it starts right from the mission, which is having a multidisciplinary activities are going on to design a mission for hypersonic system. And we are utilizing the MDO, that is multidisciplinary optimization tools, to develop this hypersonic system. I will just go to next slide to explain you why we need the MDO. Typically in any of the missile system, once globally the parameters are being defined, say I want to engage some particular target at so and so range and all, we can decide or we can design various subsystems like aerodynamics, propulsion, control, structure, all can be done independently, and in the system engineering concept level we can combine and give a integrated solution. But that is not so true for the hypersonic system. Each of these components are so much interacting with each other that any change in one of the parameter of aerodynamics will have a strong impact on the propulsion system. This is why I am saying that the scramjet operation works on the principle that it sucks the air from outside, compress it inside, inject the fuel, and accordingly the thrust will be generated. In case if the compressions are not up to the level, the injection will not be efficient and we will not be able to generate the thrust. The drag will overcome and the mission will stop there and there. So all these parameters are so much interlinked with each other that we have to optimize not only at the subsystem level, but at integrated level the optimization is required, and which is very complex. So thereon we are utilizing MDO kind of approach, that is multidisciplinary optimization. The design should be having a preemptive kind of algorithms where we can make use of the artificial intelligence and machine learning algorithms to decide that, yes, I may be entering into that danger area. I should take these corrections now itself so that I should not enter into that danger zone. And this all is happening in the real time. And the point I am mentioning that the stoppage or the drag taking over the thrust will be in the duration of millisecond. So it to be very, very careful while designing this. Apart from that, the autopilot, the engine control, the guidance scheme, all need to be decided to be at a very high updates, at a very precisely it should be done. Like the guidance scheme, as I was mentioning, it can be avoiding the in-between enemy air defense system, but at the same time, once it reaches to the terminal target, where the target can be like a ballistic missile silos or can be missile on the launcher, this can be a target, there can be power plant, there can be aircraft carriers. So for each of these categories, a different kind of a terminal guidance requirements are there, and we need to decide accordingly. Sorry. Yeah. So the next, apart from mission, the next one is the scramjet engine design. And the scramjet engine design, as I was mentioning, that it is a strong function of how the aerodynamics has been linked with this propulsion. So how the system works is, from the nose, it starts capturing the air inside, and within the inside, once the air has been captured, the vehicle is traveling at 6 to 7 Mach, and after the air has been compressed, the Mach number of that air will be of order of 2 Mach. So 6 becomes 2, and within that 2 Mach, we will be injecting the fuel. And with these combustions, all the chemical reactions, the thrust will be generated. And with that, the missile will continue to travel with 6 to 7 Mach of speed. These scramjets are very, very effective at those high Mach number compared to the traditional ballistic or the rocket motor boosters, which are having a typical ISP of 200 or 250 seconds only. The scramjet construction I am showing at the bottom, it is also a complex in the nature that once the combustion start, the temperature within the combustor will be of order of 2000 degrees centigrade. So we need to have a special class of materials also which can sustain this high temperature. It is not for 1 second or 2 seconds, we are talking about the thousands of seconds. So what is to be done is, apart from the material, we are also utilizing the fuel itself to cool down this structure. So the fuel which we are used for the combustion will also pass through via channels which will be surrounding this combustor, and will always keep the combustor temperature within check. But while doing so, my fuel start absorbing this temperature, and there may be a chemical property deterioration of this fuel itself. And once I deteriorated fuel, if I enter again combustor, I will not get the thrust. So all these are again playing with each other, and he will having, all of them are having their own constraints. We need to work along with those constraints. So as I was mentioning, our basic limitation of these missiles are with respect to the materials. We have to have those materials which can handle these high temperatures, and the characteristics of these materials also changes along the temperature. So something which is showing a good strength or good shear stress capability at low temperature, but as we go to the elevated temperature, the entire chemical properties of the material changes. Due to this, it is very difficult to have a guidance and control, also very difficult for this system. It cannot be like the missile will behave in so and so manner. No, as the temperature rises, the missile properties are keep on changing. The dynamics are keep on changing so drastically that guidance and control need to think that here, look, I am at this mark and so high, I should do doing some X kind of algorithm rather than going for Y, and all this in the real time. The next important concept for this hypersonic technology are the optimization of this subsystem weight, the length, or the miniaturization of the system. We cannot go with the big, heavy kind of subsystems, because finally I need to carry those also for thousands of seconds. So miniaturization is another area we need to focus upon. This is a typical scenario I am showing for the American missile, that is X-51. And here my focus is, if you see, there are various color codings are there on the missile. And these are all different class of material which has been used to make a single missile system. Like on the nose side, it is made of the tungsten. Similarly, on the skin is there, which is aluminum, and over to aluminum we are putting some kind of tiles. So tiles are being attached on this airframe of the missile, and these tiles are responsible to reduce this temperature, which is on outside the temperature will be 1000 degrees centigrade, while inside the missile the temperature will be of the order of 50 degree to 70 degree. So these all temperature need to be controlled. There will be controlled temperature within the missile of order of less than 100 degrees centigrade, because our electronics equipment works mill standard as 70 degrees centigrade only. Similarly, for the combustor side also, apart from the fuel, we are also having a coating which can handle these very high temperatures. The next category for the hypersonic systems, I should say that a lot of infrastructures are required to test these hypersonic missiles. And the testing facility starts right from the aerodynamics, where hypersonic wind tunnels or shock tunnels comes into picture to understand the behavior of these aerodynamics once the missile flies at that speed. We do have our hypersonic wind tunnel facility in Hyderabad, where we have tested, and we can test up to more than 12 Mach speed. Engine also need to be tested. So we do have a direct connect facility, where the reported one in the literature is by China, where they had demonstrated on ground up to 600-second duration with this facility. And today we have a facility where we can cross even beyond those numbers. Very recently we have demonstrated also 120-second scramjet operation. It was also on the newspaper. This is first time we have done in India. Thermal wise also, I was explaining that we do need silica kind of tiles which will take care of these high temperatures. We do need high enthalpy erosion facilities, because once the missile is traveling at that high speed, due to friction and all, those tiles will get eroded. And once the erosion occurs, again the temperature will leak through these tiles and comes within the airframe. Any high temperature touching the airframe, it will disintegrate there and there itself. So those things need to be tested before we go for the flight. Manufacturing is another important concept. So here I was talking about the entire philosophy, the subsystem level optimization, but finally we need to manufacture it. And for that purpose, we do need high temperature composites are required, ultralight insulation materials are required, And the third important point is additive manufacturing facility. So now we are entering into the area of 3D printing, where I should be in a position to develop these missile configuration 3D printed hardware so that I can go for flight as early as possible. Uh, we are doing this R&D infrastructure for other testings as well. I will just mention about these few one. So this thermal barrier coating, which I was mentioning to reduce down the temperature within the combustor, we are working along with various industries and research center. The coating thickness here I am talking about is less than 1 mm. So with this less than 1 mm, this should be in a position, because I don't want to get into more higher thickness of coating, which itself will get eroded once the combustion happens. And again, the system will disintegrate. There is a very high probability of that. So coating thickness, the coating characteristics, its thermal conductivity, all these matters, and we need to design and develop those kind of high temperature thermal coatings. Finally, when I'm looking for the terminal engagement, I am looking towards the seeker kind of system, where I can use the radio RF seeker or even the electro-optical seeker, but that will be housed inside this missile, which will be seeing this complex high temperature of more than 1000 degrees centigrade. So the material of this nose or the hood should be radar permeable, as well as it should sustain those high temperature. So for that also a lot of activities are going on. And the endothermicity of the fuel, that is, I was mentioning the fuel itself will be used to cool down its combustor, but its property will get degraded once the temperature rises to high value. So we are working on how to improve these fuel characteristics by adding certain kind of additives. So a lot of research activities are going on. By adding these additives, can we have a fuel which will survive for long duration? I just want to mention one point, that when we discussed with the Russian team, they come up with the solution that they can provide a fuel which is of this endothermicity, high value of endothermicity, and the costing was nearly 2 lakh per liter. But here recently we have developed in-house, and our cost is 200 to 1000 rupees per liter. So it is an indigenous solution being developed by India. So I can say these are all pictures what we are having. These are our facilities are there, and lot of activities are being done in all these critical technologies. But now our focus is on these 4 major vertical area, right from the fundamental research, where we are discussing with our academias also, because we need their support to carry out these fundamental research, like in the field of the aerodynamics or aeroelasticity. Aeroelasticity, I'm mentioning that once the missile fires at that high speed, it starts bending. So it becomes a flexible body. And once the missile becomes flexible body, the controlling will be very, very difficult. But it is a normal class missile. Here I'm talking about the hypersonic, where the temperature will also come into picture. So it's become a aero-thermo-servo-elasticity, which itself is a very complicated topic. Apart from the fundamental, we are also working on the applied research. For that, we are in touch with the industries also to develop the scramjet engine manufacturing. Optimization of this hypersonic configuration, we are working with the academia. Thermal management, computational experimental research. We have at DRDO new petaflop facility has also come up, where we can do petaflop 10^12 and more. Very high computations are possible now, and those are required to do this kind of CFD analysis for hypersonic system. Material manufacturing realization, we are working along with the industries to develop these high temperature material, 3D printing and all. And finally, it comes to the ground testing and flight demonstration, whereas various facilities are being developed, and very soon we'll be going for the ground trials, followed by the flight trials of this missile system. So I was mentioning about the technical collaboration. Here DRDO has initiated a center of excellence. There are total more than 16 center of excellence throughout the India, where we are working with the industry and academia. So the term is DIA. And the synergy has been brought out to work in this particular hypersonic area, and mostly focusing on the fundamental aspect. And yes, hypersonic is a niche area, so we need a very highly skilled manpower and resources to give us edge on this technology. So apart from the academic industry, we are also looking towards the startup industries to help us to develop these critical technologies. One of the example is like the battery, because the fuel, as I was mentioning, which is used to cool down the combustor, this fuel need to be pressurized and pass through those channels. And for pressurization, we need some kind of pump. And for that pump, we need some power station. Power station comes from the battery. We need those battery systems which should be lightweight and which should be providing us high power throughout the duration. And duration means thousands of seconds. So lightweight batteries providing thousands of seconds high power is what one of the requirements we are discussing with the industries and startups to come up. So now coming to the experience in this field of hypersonic technology, we have already demonstrated our hypersonic test demonstration vehicle on 12th of June 2019, where we have shown the 20-second flight duration in at 30-kilometer altitude, and we were at Mach 6. Very recently, we have also conducted a long-range anti-ship missile system with a hypersonic capability. It was fired on 16th of November from Dr. APJ Abdul Kalam Island of the coast of Odisha. And we also had active cooled scramjet engine test, ground test, where we have demonstrated 122nd, and very soon we'll be covering, we'll be crossing the 3-digit number also. So with these technologies and activities going on, DRDL is going to initiate a long-range hypersonic cruise missile mission. You might be heard about the program Vishnu. So they will be developing these missiles which can handle target up to ranges of more than 2,000 kilometer. And we are saying it is a program, that means the missile will be capable of firing from not only from the land but also from the air as well as from the ship. So all these critical technologies I was just mentioning a few of them, and they are all under progress, and we are improving our TRL, and all our effort is to have a weaponization as early as possible. So with this, I just want to conclude, and let us make our nation Atmanirbhar in the field of hypersonic missile. Thank you so much.